Tree versus graph. After going through the lectures on trees and then through the lectures of graphs, you would have felt a lot of similarities between trees and graphs. The reason is, tree is actually a special type of graph. What is the speciality? The speciality is that tree will always be connected and acyclic. So any graph that is connected and acyclic is a tree. When do you call something as a graph? Whenever it has some nodes and then there should be some edges. Let us say these edges are present, then you will call it a graph. Is this connected? Yes, it is connected. Is it acyclic? Yes, it is acyclic as well. So it qualifies to be a tree, but the reason you don't feel it like a tree right now is that you generally show tree in a particular manner. You always show root on top, then you'll show different children coming out of it. This is how you generally draw a tree. The reason is a graph may or may not have a root. So for graph, all nodes may be equal, but for a tree, there should always be a root. So a root is necessary for a tree. This is because one, you identify the tree by its root. Secondly, if you want to do any traversal or something, in a tree, you should always start from the root. So any set of nodes and edges is a graph, but it can be connected, it cannot be connected. Cycles are also allowed in the graph. So if you have any tree and if you add any cycle in the tree, then it becomes a normal graph. For example, if you connect these two edges, then it is no more a tree, it is a graph. So this is the concept. One thing you have to be careful is about root. That is, tree should always have a root. Another thing is the number of edges that are present in a tree and a graph. So in case of a graph can have any number of edges. There is no particular restriction that you have these many number of edges in a graph. But coming to a tree, if there are total of n nodes in the tree, if you count all the edges, they will always be n minus 1. This is true for any tree. For example, if I take a tree like this is my tree, 2, 3. This is my tree. Let us count the edges first. 1, 2, vertices. 3, 4, 5, 6. So there are total of 6 nodes in this tree. When you have 6 nodes, then you have 5 edges. That is what we just learned. Let us count the edges. 1, 2, 3, 4, 5. So this is having 5 edges because it is having 6 nodes. So in any tree, if you are having n edges, n vertices, then it will be having n minus 1 edges. This is true for any tree. Then how do you traverse through a tree and a graph? In a tree, we already learned in the tree lectures that if you want to traverse, you will do either pre-order traversal or in-order traversal or post-order traversal. This is how you generally traverse through the tree. In case of graph, you have two kinds of traversals. One is breadth first search, whenever you want to search along the breadth of the graph. And the second thing is depth first search in the graph, whenever you want to go through the graph in depth order. So about both of these we'll study separately. Next thing is, where do you actually use the graphs and where do you use the trees? Graphs, you generally use it in social networks or maybe road maps, something like that. And what about trees? We already discussed, we use trees in file systems or any sort of organizational hierarchies. If you want to represent, you will use trees. So these are the main points. Then there is also that there may or may not be a path between any two nodes in a graph. If you have a graph like this is a graph. There is no path to reach from this node to this node. For example, if this is A, B, C, D, you have no way of reaching from A to D. Still, this is a graph, just that it is not a connected graph. But in a tree, you will always have a path from any node to any other node. And one more speciality is, if you take any node in the tree and you want to go to any other node, there will be one and only one path. So if you take any node and see, if I want to go from here to here, there is only one path I can follow. I have to come down here, then to the left. So this is true for any two nodes in the tree. If you want to travel from one node to the other, there will be a unique path in the tree. And traversal, whenever you want to do, in case of graph, you are allowed to start from any point. There is no particular route for a graph, but in a tree, all traversals have to start from the root itself. If you want to go down and see any particular node, you have to start it from the root itself. One more thing is about the relationship between different nodes. In case of graph, there is no particular relation required. Like, relation can be arbitrary. We don't define anything particular. But in case of tree, you have a clear parent-child relationship. You take any node, you have a clear relationship that this node will be a parent of this, will also be a grandparent of this, and so on. So you take any nodes in tree, you will always have a parent-child relationship. But in case of graph, there is no particular relationship defined. It can be arbitrary.